Today, I am going to discuss about the Wheatstone bridge. Dear student, this topic is very important because your practical is also based on the same topic or is works on the principle of the Wheatstone bridge here. And Wheatstone bridge is a device with the help of which we can find the unknown resistance of a conductor. व्हीटस्टोन ब्रिज एक ऐसी डिवाइस है जिससे हम किसी भी अननोन वायर का रेजिस्टेंस दिखा सकते हैं। और व्हीटस्टोन ब्रिज में करते क्या है? इन व्हीटस्टोन ब्रिज द फोर रेजिस्टेंसेस बी अरेंज इन द फॉर्म ऑफ फोर आर्म्स ऑफ ए पैरेललोग्राम। एक पैरेललोग्राम के जो भी उसके साइड हैं उसी के अलावा हम चार रेजिस्टेंस को क्या करते हैं? अरेंज करते हैं। जैसे A, B, C, D is a parallelogram and the four resistances P, Q, R, S, B arranged along the parallelogram A, B, C, D. And across one diagonal of this parallelogram, we connect a galvanometer with a key K2. And through another diagonal of this parallelogram, we connect a cell E with a key K1. कहने का मतलब ये है कि व्हीटस्टोन ब्रिज अरेंजमेंट में चार रेजिस्टेंस को हम किसी पैरेललोग्राम के चार साइड से रिप्रेजेंट करते हैं। और इन चारों रेजिस्टेंस जो लगाया हूं मैंने P, Q, R, S, ये P, Q, R, S हमने चार रेजिस्टेंस लिए हैं, जिसको कुछ किताबों में R1, R2, R3, R4 भी ले सकते हैं, आप कुछ भी ले सकते हैं। तो ये P, Q, R, S जो चार रेजिस्टेंस लगे हुए हैं, इन चारों रेजिस्टेंस को हम इस तरह से अरेंज करते हैं कि जब इस की K1 को हम क्लोज करें तो ये सेल यहां पे करंट I भेजेगा और ये करंट I at point A it divide in two parts, I1 and I2. I1 will go in the part AB suppose and I2 is going in part AD. But what I am saying, the resistances P, Q, R, S are arranged in such a way, इन रेजिस्टेंसों को इस तरह से अरेंज किया जाता है कि इस K2 की को हम क्लोज करें फिर भी इस गैल्वेनोमीटर में कोई करंट नहीं आती है। इसका मतलब ये गैल्वेनोमीटर हमको क्या दिखाता है? नल डिफ्लेक्शन। नल डिफ्लेक्शन का मतलब जैसे ये गैल्वेनोमीटर है तो बच्चों जब गैल्वेनोमीटर को देखोगे, गैल्वेनोमीटर में ये सेंटर यहां जीरो बना रहता है, यहां जीरो है और बाकी ये सब डिविजन्स बने रहते हैं दोनों तरफ इस तरह से। और ये गैल्वेनोमीटर की निडल रहती है, इसको कहते हैं सेंटर जीरो गैल्वेनोमीटर। और जब गैल्वेनोमीटर की निडल सेंटर मतलब जीरो की तरफ पॉइंट आउट करेगी, इसका मतलब इस समय इसमें कोई भी करंट नहीं है। तो इन रेजिस्टेंस P, Q, R, S को हम इस तरह से अरेंज करते हैं कि ऑन क्लोजिंग द की K2 this galvanometer shows null deflection, and when this galvanometer shows null deflection, even cell is giving the current, then no current is passing through this VD, and this condition is called balance condition of this Wheatstone bridge. और जब व्हीटस्टोन ब्रिज बैलेंस कंडीशन में होगी तो उस समय P और D के अक्रॉस पोटेंशियल सेम हो जाता है। फिर से सुनिए, पोटेंशियल अक्रॉस B and D becomes equal in balance condition of this व्हीटस्टोन ब्रिज। और जब पोटेंशियल दोनों पॉइंट पे बराबर हो जाएगा तो पोटेंशियल डिफरेंस जीरो होगा, तो इसमें कोई भी करंट फ्लो नहीं करेगी। एंड इन दिस केस व्हेन नो करंट इज पासिंग थ्रू दिस गैल्वेनोमीटर, then the current given by this cell, which is I, here divide into parts I1 and I2. Since no current is going in BD, same current I will come in BC, and yes, same current I2 will come in DC, and again this I1 and I2 will meet at the point C, and final current I will return in the negative terminal of the cell. It means only you remember this: if the bridge is in balance condition, then the galvanometer which connected along BD will show the null deflection. Now our aim is to find what should be the relation between P, Q, R, S under balance condition of Wheatstone On pressing the key K1, then cell will send the current, and P, Q, R, S be arranged like this one. On pressing the key K2, हम यहां से सेल से करंट भेज रहे हैं और P, Q, R, S को इस तरह से अरेंज किया गया है कि जब की K2 को हम क्लोज करते हैं तो ऑन प्रेसिंग द की K2 व्हेन नो करंट इन आर्म BD, मतलब इस आर्म BD में कोई करंट न आए, जबकि आर्म AB और AD में जा रही करंट, लेकिन इस आर्म में कोई करंट नहीं आ रही है, then bridge is said to be in balance condition. इस समय ब्रिज किस कंडीशन में कहलाती है? बैलेंस कंडीशन. और यू कैन से व्हेन दिस गैल्वेनोमीटर शोज null deflection. तो इन बैलेंस कंडीशन नो डिफ्लेक्शन. नो डिफ्लेक्शन इज आल्सो कॉल्ड null deflection. And in this case, when we apply the Kirchhoff's law, because our aim is to find what should be the relation between P, Q, R as per the balance condition of Wheatstone B. So that condition we can obtain by using the Kirchhoff's law. For finding the condition for the balance condition of this Wheatstone bridge. Now, applying Kirchhoff's which law? Second law. For closed loop A, B, D, A. It means in this closed loop A, B, D, A, you are taking suppose clockwise or you are moving in the clockwise direction. And again you apply this concept for this. How can we apply the Kirchhoff's second law? Already I have told you in the previous video. First, your path is A to B, B to D, and then D to A. So first, when you will move from A to B, so your direction is AB, current is also along AB, means in the same direction which is passing through the resistance P. So this current I1 will taken with what sign? Negative. So we write here minus I1 into P. Minus I1 into P. Along BD, no current, nothing is there, only it is complete the circuit. And again D to A, when we will come from D to A, then our direction is from D to A, current is from A to D. It means our direction of motion and current both are in opposite direction, which is passes through the resistance R. So this current I2 will taken with what sign? Positive sign. So we'll write plus I2 into R. This should be equal to, since there is no any cell, nothing is there, then all these things should be equal to 0. Or you can say, when you will take I1P this side, then you can write here from here, I1P is equal to I2R. Suppose this equation number. Similarly, for closed loop, now suppose another loop you will take B, C, D, B. For closed loop, B, C, D, B. This one, B, C, D, B. It means again you are taking clockwise. And already I told in the previous video, इससे कोई मतलब नहीं है कि आप क्लॉकवाइज जाएं चाहे एंटी क्लॉकवाइज, रिजल्ट आपका हमेशा सेम आएगा. So when you will apply Kirchhoff's second law in this loop B, C, D, B, again you apply B to C. So your direction B to C, current I1 which is passing through this Q is also along B to C. So this current I1 will taken with what sign? With what sign? Minus. Minus I1 into Q. Again C to D. Your direction and current which is passing through this resistance S both are in opposite. So this current I2 which is passes through this resistance S will take it with what sign? Positive, plus I2 into S, and this should be equal to 0. Simply you can say this minus I1Q will take one side. So from here I1Q is equal to I2S. Suppose this equation. And when we divide the equation 1 by equation 2, it means simply on dividing equation 1 by equation 2, on dividing equation 1 by equation 2, जब इस इक्वेशन 1 को 2 से हम डिवाइड करेंगे, देन यू विल गेट I1P अपॉन I1Q is equal to I2R upon I2S. Or simply you can say I1 is cancelled by I1, I2 is cancelled by I2. So P by Q is equal to R by S. It means this is the condition for balance condition of Wheatstone bridge. It means this bridge is said to be in balance condition when the ratio of adjacent side of this resistances of 1 be equal to the ratio of adjacent side of the resistances for the other pair. It means simply you can say P by Q is equal to R by S, or simply you can say P by R is equal to Q by S. It means if it fulfills this condition, then this bridge is said to be in balance condition. So this is the condition for null deflection, or simply you can say this is the condition for balance condition of Wheatstone ratio. I hope this one is very clear to all of you. And now, what conclusion you get here? There are some points which is very important for this. In this relation, P by Q is equal to R by S. If any three resistances be known, suppose P, Q, R is known, then by using this condition, we can find the unknown value of S. First thing. Second thing, this bridge is said to be maximum sensitive when all these resistances P, Q, R, S is taken of same order. And third point, in the balance condition, if the position of galvanometer and cell be interchange, अगर बैलेंस कंडीशन में हम इस गैल्वनोमीटर और सेल के पोजीशन को चेंज भी कर दें, फिर भी इसके नल डिफ्लेक्शन पे कोई फर्क नहीं पड़ेगा. तो dear student, always you remember this. Wheatstone bridge is very important topic, and there are the two devices which works on the principle of Wheatstone bridge. First one is the post office box, and second one is the meter bridge. In your syllabus, meter bridge is given, and in your practical, maybe the first experiment of the electricity is also depends on means meter bridge works on the principle of the Wheatstone bridge here. So dear student, in the next video, I will give you meter bridge and what is the possibility for this one for error, how can we remove it here, because that experiment which works on the principle of Wheatstone bridge means meter bridge is very important here. So thank you.